Okay, so problem two, it's very similar to what we were doing in problem one. You can remove any one of these three members uh, in order to get a relatively simple problem. Because of how you have this 2EI system in here, this 2EI from here to here and 1EI from here to here, and because of how this force P acts on the frame, it actually does not matter which one of these you remove. For example, even if I remove BY, I will still have to cut my diagram at B due to the fact that I have this 2EI force, or this 2EI dimension. So because these two things change thickness, let's say, I still have to be very careful with how I partition my diagram. Now, let's look and see what happens here. So, again, I'm very hesitant to show too much on this because I'm afraid that if the way I do it is the way that everyone else is going to do it that watches this, that hasn't started it yet. And then if people have started it yet and they don't do it, haven't done my way, then it's a little bit hard to follow. But at the same time, there's a couple of points that I kind of want to illustrate. So I'm going to go ahead and remove by first. Personally, to me, I don't like dealing with overhangs. They complicate things a little bit, so I prefer to just remove the center support, get a simply supported beam, and go from there. So if I do that, right, I have some original form here, right? I'm gonna do the yeah. Let me just put that this is L on 2, L on 2. This was L. Let me say that this is 2EI, and this is EI. So I'll just draw out the moment diagrams for now because this is a relatively simple case, right? It's just 2 point loads. I'm gonna do superposition here. I'm gonna draw them separately. So let's do my, this was P first. Let me do this one first. This is my P1 system, and my P2 system will be with this force there, and my Q system will be this one. Okay. So now let's look at this MP1 system. For my P1 system, my shear diagram, do you guys agree that like if I have this force down here, I'm going to have some upwards reaction and some upwards reaction? Like down here, I'm going to have some downwards reaction and some downwards reaction. I'm going to have some downwards reaction and some downwards reaction here. And that's just due to the way there's a certain amount of symmetry here. And that will cause these reactions. So I'm going to neglect values for now, but immediately I know that my shear diagram for the P1 system is just going to go straight up first, go across until P, go down, and go back across. And if I were to actually find values, I think this one should actually be 3/4 P, and this is going to be negative P on 4. So those are my values. My moment diagram is just going to look like this. This height here is equal to this area. What is this area? It's 3/4 P times L on 2 is 6P, is 3PL on 8. Okay, so that is the area for that one. My BY diagram, I'm going to get something that looks a little bit different. I'm running out of space here a little bit. My BY diagram is just going to be like this. Right. And I should put here that this is equal to by on 2 times L. My Q system is going to look like, it's going to look very similar to this. Right, so my Q system will just be like this, except my Q system is essentially a case where by is equal to 1. So I would just get a height here of of L on 2. Okay. So now I think a lot of you are probably asking, like, where does this 2EI come in? It doesn't come in until after I try to find the deflections. So first off, I'm going to go ahead and split this up into 3 separate sections here. So I'm going to split, because I have a peak here, I'm going to go ahead and cut this down here. Because I have a peak here, I'm going to go ahead and cut this here. And for these two, for this half of the problem, this is all 2EI. And for this half of the problem, everything is just EI, right? So what am I going to do? I'm going to go back to that table that I have. I'm going to do MQ times MP. So I'm going to do, I go to this table, I'm going to do this triangle, and let's put values in this. So there are numbers in here. So let's use red here. This is 1, 2, 3. This is 1, 2, 3. My deflection at B is going. I'm gonna do this by parts, right? So I'm gonna do this part, this MQ system times MP1, this MQ system times MP2. This MQ system times MP1, this MQ system times MP2, this MQ system times MP3, or MP1, and this one times this one. So as you can see here, I'm gonna have a lot of terms, but this is actually fairly easy to solve, right? This is a triangle times a triangle, triangle times a triangle, triangle times a triangle, triangle times a triangle. The only tricky part is in the center here, where I have a trapezoid times a trapezoid, trapezoid times a trapezoid, and even then, all you have to do is be a little bit careful with your similar triangles. So for example, I know, and to find, I need to find the heights of these three values here. Height of the triangle at this point, that's just the ratio of this base to the total base, or not the total base, but the base from here to here. If this is L, and this is 3L on 2, then this height is just 2/3 of 3PL on 8, or this is equal to PL on 4. And then I'm going to do something similar here. This one is going to be half this one. This one will be half this one. Sorry. This one will be half this one. This one will be half this one. So it's really not too much work. It is long though. It's not hard, but it is, once you have this diagram set up and you know how to draw from the tables, it's not particularly hard. You just have a lot of little calculations you have to do, and that gets quite tedious. Just a word of caution here: when you're using these diagrams, it's very important that you match side to side. And what do I mean by that? Let's look at this trapezoid, for example. Trapezoid times a trapezoid. I want to make sure that when I'm comparing my Q system to my P system, my M1 and my M3 are on the same sides. Right, so my M1 and my M3 are on the same side, my M2 and my M4 are on the same sides. It doesn't matter as much for some of the other shapes, like for a rectangle, for example, it doesn't matter. It's constant all the way across. I can use any value that I want. For the triangle, it does matter. The difference, as you can see here, if my bases are on the same side, I use one equation. If my bases are on opposite sides, here and here, I use a different equation. And these are not the same equation. They're off by a factor of 1/2. So that's just about everything for this problem. I think I don't think I can go any more further into this without getting into a lot of numbers, and I prefer not to do numbers in these videos. So if you have any specific questions on this problem, or even just more general questions on like how to do the procedure for this, let us know, and And we'll try to help you if we in any way we can. Obviously, let us know if you have any other questions. Oh, I forgot I forgot to mention it when you're doing this one. You're going to divide these sections by 2EI and this section by just EI. Right, so you'll have MQ times MP divided by 2EI. MQ times MP divided by 2EI. Over here, you're going to have MP times MQ divided by EI. MP times MQ divided by EI. Yeah, so now with that, let us know if you have any questions.